Mic check 1 2 1 2. Okay, mic check 1 2 1 2. Mic check 1 2 1 2. And then we are here. I hope I hope I can be I hope the sound is fine today because last time we've been trying to we've been trying to do this question, but then I it couldn't happen because of the sound. This was the question that we were trying to do. Where should I? All right. Yeah, man, this was the question we were trying to do last time. Couldn't work out because of the way things were in terms of the sound. I felt like today be a bit better than it was the other day. So let me just get the question also on my side. So the question reads, okay, from my side, I only access the question from my phone. So the question reads, um, the graph of the function f of x is given like that, and we have f of x is given like that, and they are drawn into the graph below, which is this graph. I'm not sure how close it is on the other side, but then I feel like anyone wants to see if they can zoom in. But then, yes, this is what we have. So we have two functions. Let me write that down. We have two functions. We have one function. We have this function. And then we also have these are the two situations we have. We have f of x is given like that, and we have g of x is given like that. We have two functions. And the diagram looks more or less like this. But try to draw it closer. So we're gonna work around something like this. So this is our f of x. So yeah, man, this is f of x. This is f of x. and this is g of x. This should be, this whole structure should be similar to this. The whole structure should be similar to this. So as we can see, that's f of x, g of x like that. And then now, I think we can go to the first question, right? So the first question they say, they want us to write down the coordinates of the turning point of f. They want us to write the coordinates of the turning point of f. Here is the question. Here again, question one, 5.1. Write down the coordinates. Write down the coordinates of the turning point of f. So this is how we do it. Well, first of all, in a graph, in a graph, it's just, we call it a Cartesian plane. We plot a graph in a Cartesian plane. We have the x-axis, we have the y-axis. We have the positive side, just like the positive side of a number line. We have the negative side, just like the negative side of a number line. Then that's the one. The, oh man, sorry. This is the y-axis. This is the x-axis. It's just that on my other way, probably the video was upside down. So my apologies on that one. My apologies on that one. I think probably the board on the other side is just look at it like that because I want you to receive it on the other end. It should be on paper. So this is the x, the y-intercept, the slope, and this is the x-intercept. So like I say, this is the positive side. So the way it works is like going this side is plus, 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 plus. Going that side is minus, 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 minus on the x-intercept in terms of values. So you'd get probably plus 3 there, plus 5 there, 10 there, up to infinity. Same applies to the negative side, to negative infinity. So also when you look at the axis, we have the plus, 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 the y-axis going up. We have minus, 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 the y-axis going down. So that's why we represent our slope. So suppose you are drawing a straight line in this case. If you have a straight line, we all know that a point at any given point of the graph is given by the y-axis and the x-axis, y-axis, x-axis like that. Hence, mathematically, determine a point like this. We determine a point like we say a point is x and y. This is how we determine a point in algebra. Meaning, it can give you a random number, let's say 2 and a 7, and they say this represents some sort of a point in a graph. You should just know that in this case, x is actually 2, and then y is actually 1. So all you need to do, all you need to know is that in a point, the x side of it, the right hand side, the whole point, the right side of it, I mean, and the y side of it, on the right hand side. So that's how we represent it. So the communication within this language, just like any other language, whenever someone just say whatever, whatever about this is through the 2 points, they say one of the points is 2 and a 7. Without, okay, let me use a different figure there. Let me say maybe a minus 1 and a 10. You just know that at this point, the value of x is minus 1 and the value of y is 10 in terms of this point. That's how we normalize, or rather, by definition, that's what we call a point. So always think of x, y whenever you think of a point. But then going back to my graph, they want us to determine the turning point, right? So the turning point is from f of x. This is our f of x. But the way f of x is given, like you can go straight because um, normally the quadratic formula is like this: f of x is equals to uh, a x squared plus bx plus c, right? But then if you complete the square on this, somehow it ends up being f of x now is equals to a x minus p. Let me just confirm.